My dear students, today we are going to see what happens when metals are burnt in air. So, or otherwise, you can write like this: action of air on metals. Action of air in the sense it is oxygen reacting, metals reacting with the oxygen. That is nothing but a burning process. It is whether it is a the fast or we call it as a combustion. It is a slow combustion or a vigorous type of a combustion. It depends upon the metals, how do they react with oxygen. So here I have kept some of the metals here. Let us see how do they react. I have kept here the magnesium. So magnesium, what we have to do is we have to burn the magnesium. We have to heat the magnesium here and burns with the white dazzling light, and that the white flame is nothing but a magnesium oxide. That white flame or the white ashes what we get, it is nothing but a magnesium oxide. And now let us see what happens with the aluminium. So here in case of aluminium, so it is a slow combustion. When you expose the aluminium materials in air, when the aluminium exposed to air, what happens is you will find or you will see the rust, the aluminium get rust, or you will find the grayish white color, the powder or the material accumulated on the aluminium. That is nothing but a aluminium rust. We call it as a aluminium rust. That white, grayish white color powder. It is nothing but a aluminium oxide. So we had some the apparatus here in the lab, which we have kept in the cupboard, and after some times we are observing this. That is aluminium oxide or the aluminium rust. We are finding this. You can see here. See, okay. The next, in case of a copper, you are very familiar with the copper. So I have kept here one of the copper rod here. What I am doing is here I am heating a copper rod. I am heating copper rod here. So I had already kept it for heating. So after some times you will observe the black color layer or the black color coating on the copper. That is nothing but a copper oxide. You are finding this. That is nothing but a copper oxide. That black color layer or a black color coating. So that is nothing but a rust iron, or it is also called as a hydrated ferric oxide. Why? Because here in case of iron, the iron is reacting with the moist air here. That's why we call it as a hydrated ferric oxide or rust iron. We call it as a rust iron. These are the common things which you are finding in your home or anywhere. So that's why what we do is we always paint the metals, okay, or anodize the metals, okay. The next is in case of a sodium, we have here. So in case of a sodium and potassium react vigorously with the air and they catch fire. So here the process is slow because it is kept in a wax coating. In order to show you that, so I am putting a small piece of a sodium in a water. Let us see how vigorously it is reacting with the water. You can see here that sound. You please listen to that sound. That is a hiss sound. Okay. So how vigorously they are in a reactive series. The sodium and potassium are the topper side. Why? Because they are reacting vigorously with the air and they catches fire. So this is the simple activity I am showing you. Now finally, the metals when react with oxygen, they produce metal oxide. That is the final result. So here on the board I am going to give you some of the reactions you need to write. Okay, here in the case of magnesium when react with oxygen, so you find the white dazzling light there. So that is nothing but a magnesium oxide, MgO. In order to balance this, you can write here Mg2MgO, that is nothing but a magnesium oxide. So here the particular word you need to concentrate on that word, that is a dazzling white light, dazzling white light, or that white ash. White ash is nothing but magnesium oxide. So whereas in the case of aluminium is slowly reacting. When aluminium is exposed to air, then we get aluminium oxide, Al2O2. So in order to balance this, it's nothing but aluminium oxide. This magnesium. So what do you find here? So grayish white layer, grayish white layer you find on the aluminum, is nothing but aluminum oxide. Whereas here in the copper, oxygen, copper reacts with oxygen, or when copper is burned, so what happens here? It is CuO. It is nothing but a copper oxide here. You can write copper oxide. Copper oxide. So you find black coating, black layer or coating on copper. So black coating, you find black coating on copper, that is nothing but a copper oxide. Whereas in the case of this, I am going to write the moist air. So what we get is a hydrated ferric oxide, or the rust, we call it as a rust iron, Fe2O3 2H2O. It is a hydrated ferric oxide. You can write a hydrated ferric oxide, or the rust iron, hydrated ferric oxide, or we can call it as a rust iron. So we have here the brown powder on iron. So you can write brown powder on iron. So whereas in the case of sodium reacts very vigorously with the oxygen. So that's Na2O. Na2O, that is nothing but a sodium oxide. It is nothing but a sodium oxide. So I hope you got this, you understood this. So the next reaction, when the sodium oxide, when sodium oxide reacts with water, it becomes sodium hydroxide, or otherwise when sodium directly reacts with the water, that becomes a sodium hydroxide. In the next case, so the action of water on metals, or what happens when metals react with water, that in that case I am going to give you the sodium hydroxide. This case, what the activity we have done, that I am going to narrate. But at present, so what happens when the metals react with air? The finally what happens is metal plus air or oxygen, metal oxide. That will be the result. So finally, what you can write here: metal plus. So I'm going to write here in the box here, final result, metal plus oxygen. Oxygen in the case is air. The result is metal oxide. So that will be the final result. So you can write or you can take it down. Concentrate on the specific word or the specific result. So the next class we are going to discuss about how the metals are going to react with the water. Okay. So here I am burning a magnesium ribbon here. You can observe the white colored ashes, dazzling light and a white color. And finally the white color ashes here. That white color ashes are nothing but a magnesium oxide. Okay. Yeah, you can see here. This is a magnesium oxide here. So magnesium oxide and
coated with a protective layer of oxide, which prevents the metal from reacting with air. It causes the metal also to be resistant to corrosion. This gives the impression that the metal is unreactive, which is far from the truth. In this demonstration, a coil of pure aluminium wire is used. The protective layer of oxide is firstly removed by dissolving it in sodium hydroxide solution. The cleaned metal is quickly washed in deionized water and then dipped into a solution of mercury 2 chloride. Some of the dissolved mercury ions are displaced from solution and form an amalgam on the surface of the aluminium metal. This metal is washed again and quickly placed into a flask of oxygen. Oxidation of the aluminium occurs almost instantaneously, and since the reaction is exothermic, some water vapor evaporates from the wet metal surface, and you can see it condensing on the cooler glass surface. Water is essential to the oxidation process because if the flask is dried with a hot air dryer, the reaction slows almost to a stop. In addition, the reaction proceeds more quickly if the flask is full of oxygen rather than air. The process of the reaction has been filmed by time-lapse photography. This short 1-minute long sequence was filmed over a 2-hour period. The product of the reaction is an oxide, probably a hydrated oxide. This process mirrors rusting, where both water and oxygen are also needed for iron to rust.
my dear students, in the previous class we have come across how metals react with oxygen and what is the final product. When metals react with oxygen, the product is metal oxide. So here are some metals which do not react with oxygen at any temperature. For example, gold, silver, even a platinum, they do not react with oxygen even at a high temperature. So it is the reason why we can wear the gold at any temperature or anywhere, at any atmosphere or at any places we can wear this gold and silver ornaments. So we are confident that they are not going to react with the oxygen and nothing is going to happen. Okay. And the next is, whereas we have seen sodium and potassium are the metals which react vigorously with the oxygen and even they catch fire. It is the reason why they are kept in a kerosene or why they are wax coated. It is the reason. So because they are reacting very vigorously with the oxygen, therefore it is sodium and potassium are kept in a kerosene oil or they are wax coated. So here, due to oxidation or due to this oxidizing process, when metals react with the oxygen, they get corrosion, they undergo corrosion. They produce a metal oxide. We can call it as a corrosion or we can even call it as a rust, metal rust. So it is the reason where the metals are anodized so that they do not get rust or they do not get corrode. So anodizing is a process. It is done in industrial regions or in even labs. Anodizing is done where purposely the metals are oxidized and they are coated. Okay, you can see a water bottles, some of the water bottles. These are the anodized water bottles or utensils or the cooking utensils, cookers or any vessels and all. They are anodized. So anodizing is a process of forming thick oxide layer of aluminium when exposed to air. But it is purposely done. It is purposely done so that this aluminum oxide core makes it resistant to further corrosion. So in order to prevent the further corrosion, purposely the anodizing is done. So you can write, if they are asking the exam, anodizing. Anodizing is a process of forming thick oxide layer of aluminium when exposed to air. Naturally it is happening in the nature. But what is happening in the nature, we are purposely doing that. So they prevent our metals. Okay. So therefore the anodizing, the process is done purposely. So we can, by that anodizing, we can prevent the metals from corrosion. Okay. So it is a lengthy process. We can discuss in the later. Thank you.